One thing I didn't quite talk about is that on your reference sheet, I don't know if any of these are actually here. And that's because they use this form over here. I use purple for this one. So they actually use this form for the integral of exponential functions. And you might be wondering, hey, how come this isn't the one that we use in the textbook and things like that? Well, I guess for like solving problems, the ones on the left side are a little bit easier. But this one's kind of looking at, remember like with the reverse chain rule, like if you have the derivative of the outside, of this power on the outside here, you can straight up just integrate that again. It's kind of like this form over here, but a bit more generalized, right? And so that works really well for stuff like, okay, if I had e to the f of x, sorry, let's use the number, e to the 5x, and you took the derivative of that, you would get 5e to the 5x, right? And so then if you're asked to integrate 5e to the 5x, because you have this form, you can straight up just integrate it. You always forget the x's, sorry. You always straight up just integrate it and you'll get, okay, well I know the primitive of that is this form here, e to the 5x plus any constants, there aren't any in this case, right? So that's just kind of something to be aware of. And it means that you can answer, I guess, trickier kind of problems where if you had, I don't know, as an example, e to the x squared plus 2x, and we had, for example, on the outside here, 2x plus 2, right? You'd know that this satisfies the form, right? And I talk about kind of like rearranging these so that you can get the derivative, so you can get f dash of x. So sometimes that might be involved as well, but for this one, you can see how it doesn't really fit in with this form over here. But we need to think about, oh, okay, well, what's the derivative of x squared plus 2? Well, that is 2x plus 2, right? So I've got that here. I can straight up just integrate that as e to the x squared plus 2x plus your constant. And you can take the derivative of that and check that it makes sense. As far as I know, that we're only expected to straight up integrate using this form. The reason why they've given you this form, I think, is A, it's more generalized, but B, also what they might do is they might get you to do a question which says, okay, differentiate this, and then hence integrate. That's a pretty common type question. So they may give you something like this, and then you have to integrate something of a similar kind of this form, not exactly the same, because that would be too easy, right? But then you might have to do a bit of manipulation there. So that's why I suspect that the reference sheet gives you that one. So just be aware of that when you're solving the problems, okay?